Hey, 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 hey. Sound check, sound check. Alright, we are live and we even have some people in the stream. How cool is that? Let's take this text away. Yes, this stream is sort of right smack in the middle of Monday workday, at least here in Finland, so don't quite expect that many viewers, perhaps. Not that I necessarily have that many Finnish viewers. But still, nice to see some people around. Welcome, welcome. Today we're going to do a little bit of UI programming, probably. Korigami K says, hey, hello to you. What are we using to create this game? Do you mean like tech-wise, like game engine or programming language or what? We are using the Zig programming language, first of all, and we are using a game engine called Basis, which is probably one of the few game engines currently that actually support Zig. There are a few. Mag immediately comes to mind. See if we can get a browser going here. Yes, so Mac is one. One such thing you can use if you want to build with Zig. There's also the what is it, gamedev Zig or whatever, sort of like a collection of libraries and things like that if you want to build a game using Zig. But no, we're using my game engine called Basis, which is not really a Zig engine. It's written in C++, but I have exposed it to Zig using various techniques. And we are building a game called Traction Point. And the thing we are looking at currently is a HUD mockup for Traction Point. So I've started sort of imagining these well, basically I was working on interaction areas last week, even some of that on stream, and I needed to have things like this, these sort of notifications about how to activate an interaction area or how to switch to another vehicle, these sorts of things. And that got me into the whole UI mockup mindset, and I need to basically get the HUD working relatively soon. Anyway, so I did a mockup. We have a few different things here on the screen. For example, you have this this thing that I call the driving gauge, which shows you how fast you're going, your current gear, and a sort of RPM meter. So this is a car game, if you're not familiar with the project from before. And so even though it's not a racing game, it's something that I wanted to have here, sort of like an element that shows you some information about your car. There's still sort of a mock-up, but this is actually implemented in the game. I'll show you in a bit. Then you have this vehicle information, which is sort of like the base of this whole corner here in the screen. It shows you the name of the vehicle that you currently have selected. This thing, then based on what you're currently doing, you might be seeing the driving gauge here if you're just sort of driving around. You also have this vehicle control menu. This is something that we in previous streams called, actually not in previous streams, but previous videos. We actually implemented this menu together. It didn't look this nice back then, This is sort of how I imagine this UI looking. So you can have you can sort of drive around the vehicle. Some of them might have other features, such as these like cranes here. And so I kind of imagine it working so that this gauge goes away and you can sort of temporarily switch to something else. And what we currently have looks a little something like this. So we have this press E to interact, because this is sort of how you switch vehicles currently if you're just close to another vehicle. Yeah, I had a nicer version for that here in the mock-up here on the right, or the left. Sorry, I don't know left from right apparently. But yeah, it's still right here in the middle of the screen, so we'll have to do something about that. But I did actually implement this gauge here. It's not doing anything sensible yet. As you can see, it's just sort of animating through the range linearly. And this doesn't react to like vehicle switches or anything currently, so I'm gonna have to look at that as well. But yeah, this works. And we can see here we have so this is a script that I use to actually lay out these views. We have the vehicle info canvas. We have the drive gauge canvas. You can just resize these guys here directly if you want. These are vector graphics, so you can make them really large. They still look nice and smooth because they're completely vectorized. So that's pretty nice. But yes, I think it should be about that size. And yeah, I think the first thing that we'll do today is hook this thing up to the vehicle, so that we can actually see some sensible information in this thing here. And probably we need to come up with some name for this guy here as well. So let's do that. I had a spec for this already somewhat done, so I'm using checkvist to do these kinds of outlines. A very handy little tool to make some notes about the next steps that you are to take, and you can mark things as done here directly in the thing. So we have some init vehicle HUD messages already. Let's go to the game code. And I did update my Zig version and rebuild the Zig language server since last time. So now we should finally have, if I take these things away, it will be unhappy with me because we have unused function parameters. Now if I save this, it just adds them back in with this autofix comment, which is both a good and bad way of handling this, I think. This sort of signals to the CLS that okay, these were actually added by that thing. So now if you start to actually use this thing for something, I don't know, you refer to this, and now you, oh, I can do that, obviously I can do that. Now you save that, then it sort of automatically removed the autofix for the message, and obviously added that there. If you take that away and save, it will not take it away. So it's sort of a message to ZLS itself that I am the one who added this and I can take it away as well. But also means that the code gets a little messy after a while. Oh well, can't be helped. Right, so where's the UI code? Here's the UI code. We have the in-game UI view model. And we have a couple of things that we want to refer to here. So this thing here is called the driving gauge, which is kind of a stupid name, but it sort of comes from the fact that we are in the driving mode. So we have the role selection screen here. This is the thing that we want to actually switch out this gauge for. If you take another vehicle, like this huge vehicle, this mother vehicle as it is called, this guy has like a couple of roles, so you can see that it's sort of stupidly rendered behind that now, but you have like the driving mode and you have the cargo crane. So the thing that controls this crane here. And because of that, the driving mode is essentially the thing that you are in like most of the time. So this is called the driving gauge because it is the thing that will be visible when you are in the driving mode. Then we have this thing here, which is called the vehicle info something. What is it called? It's called just vehicle info. So drive gauge and vehicle info. These two guys. So drive gauge, for example, we update it here, and this is where we actually just currently, we can see the gauge amount is just incremented, and then if it goes above 1, we just set it back to 0. That's the thing that makes this sort of go up all the time, and then back down. So we can show it, we can hide it, and we can update it. And that's pretty much it. And here's the code that actually draws those things. Draws the gauge essentially, and then also renders these texts like this. So that's that. And then if we go back to in-game, we have the other one, vehicle info. Is right here. Let's see what do we do with that. We show it, and the vehicle name goes here. That's the name of the vehicle. So that just gets rendered there. And then we deinitialize it. That's essentially everything we do currently. So yeah, this thing is not really doesn't really know about like vehicle switching or anything. Axel, hey man, long time no seen. Custom C++ game engine, game logic in SIG, exactly. Indeed. So yes, I think we should be able to essentially implement the logic for these guys pretty much in its final shape. If it is indeed the final shape, but that remains to be seen. Right, so you already have an init vehicle HUD message and a de-init vehicle HUD message, which I added like ages ago. You can see here the HUD messages, init vehicle HUD, de-init vehicle HUD. So these aren't actually used for anything yet. It's just defined here, and then we register it, which every message needs to be registered. But we're not actually sending them or receiving them. So it's sort of like a half thought from some months ago. So maybe we can use those. We can send these from vehicle avatar component. So every vehicle in the game has a vehicle avatar component. If we go here to vehicle blueprints, the test vehicle is the one that we just looked at. So if we look at the preview here, they don't have any wheels here because they're sort of added as runtime. We can remove the physics. You can see that the physics, the collision doesn't even exactly match this visual yet. But that's neither here nor there. We have this test vehicle. We have two trucks. We have one which is like way out of scale. Actually, this is a huge thing. Then we have another truck which is much better scaled. Then we have the mother vehicle, and all of these guys have a vehicle avatar component added to them, which we can look at here. Here's the vehicle avatar component. This guy typically keeps track of the roles. So this has a driver role and there's a cargo crane role. This role position was essentially sort of just meant to be. I had an idea like when you switch the roles, the camera might actually sort of change a little bit and focus on a different part of of the vehicle, and I still think that's probably something that we'll want to use. But I haven't really used those for anything yet. The test vehicle probably doesn't have anything except the driver. No. This is really just sort of a scout vehicle. And so it doesn't have any other functionality yet. Maybe it will later on. And I think we will add the new information about the UI to this vehicle avatar component. And just if you're not aware, like avatar is essentially what is the object that represent the player in this engine is called an avatar. So like if we add a new vehicle here, like, and then we go like we want to be that vehicle, we can just set that as the avatar. And obviously at that point, like the vehicle name should change, and this gauge here should start tracking that vehicle instead of this vehicle. That's sort of the idea. As always, by the way, let me know if the sound levels are somewhat all right. There's a bit of a noisy room that I'm in, but I hope we'll be all right. Let me know if you want my volumes to be higher or lower or anything. But okay, what should we start with? Maybe you should think about what we actually need here. So, yeah, vehicle avatar components gets a few new BP props. So that stands for blueprint props. All of these things are blueprint props. Basically, we'll want to be able to specify the name here. I don't necessarily know if the name needs to be localized or not. I think it will start with just like an unlocalized name because it's a name, so it's not necessarily doesn't necessarily even need to be localized. And then we want the RPM, at which point we read the end of the normal range. So the normal range is essentially like this blue range here. Like, what is the RPM of the engine at the point we reach this? And then what is the RPM at the end of this red range? This is like this would be 0. This would be something, I don't know, 4,000, 5,000, and then this is maybe like 6,000 or 7,000 or something like that. But that probably differs between vehicles quite a lot. And so we'll most likely want to be able to set that on a per vehicle basis. So that needs to be one thing. Was there something else? Yeah, probably not. Not yet, at least. So we'll start with that, and then we'll have some data to actually work with here. Yeah, let's shut down the. It technically runs another instance of the game there when you're using the preview, and the preview tries to be smart and not render when you're not actually hovering over it, and then goes back to rendering when you do that, and that's why we got that choppy movement earlier, because this thing is like sort of turning on and off the renderer all the time. So yeah, let's shut that down. So for these things to be visible here in the editor, we need to actually make the editor aware of them. And that's not super tricky, but we need to see how that worked. So I have something called a UI def or UI definition file here. We can see that this is a TOML file, if you're not familiar with the syntax. So you can specify things like this. Oh, here we go. The vehicle avatar component, for example, cannot be created in a level editor and asset browser preview, but it can be created, and it indeed will be created on both client and server. And that's important because the UI is of course on the client, so we want to have it there. So yeah, supports level editor, supports asset browser, those kinds of things. Then we have like the actual blueprint properties here. So roles it's of type vehicle avatar role. I think this is probably a vehicle avatar role is itself something that has properties. So this has like a type enum with these 3 values currently, and then it has a vector 3 and some other things. I can never remember the syntax of this thing by heart, so I always need to look at some other thing to get like an idea of how this works. But let's try to figure it out. So first of all, we'll want to have the name for the vehicle avatar. Do we have like a string here? We don't, but we can most likely, let's see, we have here in the basis one, we have a documentation toml file. And this might have like a string, yeah, string. It's probably fine. We can figure this out. Let's copy one of these guys here, and we can call this something like vehicle vehicle. What should we call this? Like display name, maybe, something like that. Yeah, let's call it display name. And the type would be a string, and the default one would be probably unnamed or something. Unknown name. I don't know. Display name. And we can just copy these. We don't really need anything. And then we need a JSON name. And the JSON name is so these things actually generate JSON for us, and the game then needs to refer to the data somehow, and we need to use this JSON name to actually read the thing when the app starts up. So we don't do it at runtime. There's not like JSON parsing as the game is running, but it does everything in one go when the app starts up. But yes, they do end up in the final game in JSON form. Explicit default value is true. Yeah, that's probably fine. Put this to false, and then we input this thing. Then it just simply is removed from the data. Then we need to reload the component UI definitions, and we can reload this thing. And we go here and we find. So now we have display name, unknown name, and we can just call this like scout vehicle, something like that. Let's put in something here for these other ones. Mother. These things might actually have to be localization IDs at some point if you actually want to localize this. We'll see. Because I'm thinking like the mother vehicle, if the game is actually localized into some other language, then the mother we might want to localize that as well. I don't know. Let's just call this truck2. Truck2. Or we can do like truck2 like this. Make it look a little different than the actual name of the game object. And this would be truck1. Like so. And now then, how did we actually read these things at runtime? So we have the vehicle avatar component here. And this has something called vehicle avatar component properties, which loads things into JSON. We can see that this has a role list. A role list is a bounded array of vehicle avatar roles. And vehicle avatar role is just a simple struct with a type and a position. Like that. So, now we'll want to put in a display name here probably. Display name. And we'll want to keep this as an actual string. Right? So, well, first of all, the way we parse this currently, and this this is like the SIG standard library JSON parsing system. This is not something I have written. This has changed a few times, and I've had to like rewrite some of these things. But basically, you tell it to parse something into a type, and then the type, these members here need to match essentially like the JSON names. So we had roles, and we had, if you look at this, we had display name. This is the JSON name. So let's put a display name thing here, and we can probably just use a const slice of unsigned 8s. So this is sort of a string, or a pointer to a string. It's sort of like a const char pointer, but in Zig parlance. This should now already give us the display name here in this member, but it doesn't copy the string anywhere. This is sort of, like I said, just a const char pointer. So we need to copy it somewhere, and that's why I have this outer struct here, which has things a little more sort of organized and structured how I want them. And in here we can also have a display name member, but let's make this a basis string. And basis strings we need to actually allocate and deallocate. Display name, string, and init with the allocator that is passed in. That should be fine. Yeah, we don't have a deallocation thingy here. That's kind of interesting. Where do we actually deallocate the memory for this blueprint property? It is possible that I was trying to be smart about this and make it so that if we actually have a dinit function, then it calls it. So it would be like probably something like, that needs to be a writable pointer, something like this, and then we can do self display name dinit. It is possible that the system works in such a way that it automatically copies that. Why use a bounded array for roles and not a raw slice of roles? Yeah, that's essentially the same reason why we use a string here and not just a slice of these like string slices. So we have this this parse from slice here that we defer dinit it here, and we release the memory, and that memory then goes away. We could of course hold on to this guy and just refer to this props object as long as we need to keep the blueprint properties alive. It is kind of nice to be able to format things a bit nicer occasionally, especially if it's not super easy or trivial to represent something in some somewhat complex type in JSON. Yeah, you might want to have like IDs instead of strings in the JSON code, for example, or string hashes or something. And then you want to, because all of this stuff is run at app startup, and so you want to do essentially as much processing as you sort of can at that point to make the data nicely available for you. And so I typically do, not always, not in every case, but I typically do it in this sort of setup where I have like a full blueprint property struct like this, where the data is available in a somewhat nice fashion. And then I have this raw these raw types here, where these actually need to match the JSON data. Absolutely. Otherwise you'll get like parsing errors. But yeah, you could hold on to this and just keep them as raw slices if you want to. That's perfectly fine. And yeah, bounded array is just basically like that is it's like an std array in C++. So you give it a capacity, and it doesn't need to allocate any memory. I mean, we could just have it as like an array list here, and it would dynamically allocate that, put it on the heap if you'd like. I hope that answers your question. And that is, of course, also why we don't need to deinitialize this. Like, we don't need to free anything here. Like, there's no d in it, because this guy didn't allocate any memory to begin with. Okay. Let's have a look at the blueprint properties system code. I think it's in components, probably. Nope. Then it's probably in the factory. Create blueprint properties. Right. Set blueprint properties. And it's of course possible that I don't actually I never deinitialize those guys and just leak memory. Again, it's not that bad, because they stay alive for the duration of the program, and we don't do any blueprint property sort of processing. We don't suddenly load more of them or anything like that. But still, I'd like to actually see where they destroy them. Let's look for dinit like this. Let's see. Here we go. I immediately found it. Right. So game component factor is sort of like a generic type. So we return a new struct which has some things set up for us. Has BP props. This is a boolean, a comp time boolean, which basically checks if we have that field. And yeah, if it has a declaration d in it, then we call it, and then we destroy the blueprint props. Lucas says hello again. Hello. Welcome back. I always find it interesting that I have actual people in this in these streams. It's a nice surprise every time. Welcome back. You tried running with the general purpose allocator? Yes, I do actually. I do run with that currently. It's set up, I think, in means. That's not how you search for that. It's actually probably in main.sig, right? Yeah. General purpose allocator. Means allocator. Yes. This is basically where we choose it currently. I mean, I don't use just one allocator, but most of the components, most of the gameplay code gets fed this guy, which is not probably what I will ship with in the end, because Basis as a whole allocator system on the C++ side, which lets you look at things like if you go here, we can have a look at memory stats, for example. So here you can see, like, the yellow ones are the ones that are actually where the allocator is used currently, and it stays yellow for, I think, like a second. So the ones that aren't yellow, they haven't been used for a little while. Basically, if something is yellow, then it is like getting hammered all the time. You can see that, like, we have C++ STL, which is sort of notorious for making memory allocations. We have most of those, 23,000, almost 20. Well, now we have 24,000. These are put in sort of separate heaps, though. You can see that even though we are occasionally allocating more, the memory usage doesn't necessarily go up because they have like their own separate heaps. And so it would probably be a pretty good idea to just hook Zig into this, and you would have a Zig sort of category here of things like that. And we have like, what was it I saw? Particle 97.31. Like I don't even really use that. That's the old particle system. I have the new Merlin one, which actually doesn't use that currently, I think. But yeah. If you leak memory currently, you do get the report, which is why I was sort of expecting to find something like this. So if the type that you use as the BP prop, so blueprint property type, has a dinit function, then we call it here before we release that. It's insane how much infrastructure you have in the engine. Well, yeah, it is. It's getting to be quite large, unfortunately. Yeah, the only thing missing now is the game. Right. Let's go back to the actual work here. So now we have the dinit function, which we might want to make sure it actually gets called, but yeah, I assume it will. So now we have sort of automagically, it's not really automagically, but it's hooked into Zig's comp time system. The value will be available here in this self.blueprint properties pointer. And here is, for example, a pretty interesting function, because this guy will get called on the client when a vehicle becomes someone's avatar, on became client local avatar. There's also one that fires on the server if you're interested in that sort of thing. But here we could try this out. So let's do printf, and what do we say? My vehicle, and we format this as a string, and we do actually we can put it inside of this if here. Then we don't need to do any checks for the blueprint properties. So this would be bpp dot display name, and we need to give it the str. Sometimes making the tech is more fun than making the game itself. Indeed, that is exactly how it is, and that is the reason why I made so much tech. Oh, printf. Yeah, that is the reason why I have so much tech. Okay, so my vehicle doesn't show anything. That's not good. That's not good. We can actually probably, if we switch vehicle now, this should fire. Yes. PPP. Yeah. The debugging experience is not that great yet with Zig, unfortunately, at least on Windows. But we covered that in the last stream quite well. So Oh, of course we don't get it yet because we don't set it yet. Right, so we have it here in the display name. And here we need to now we need to do try self display name set, and this would be props. Yeah, so we don't need to actually don't want to do it inside of that for loop there. So props dot value dot display name. And it's access denied because I have the game running. Waiting for the promised Zig hot update to land. Of course, in this case, we would still have needed to actually relaunch the game. But yes, okay. So now we can see here that we initially actually have one of these trucks as our vehicle. If we put down the mother vehicle here, we see my vehicle is mother. That's cool. Now it's a truck 2. And now it's a scout vehicle. Cool. Okay, so now that works. That's good. Let's put in those 2 float values that I already mentioned that we will need for the gauge. So what was it? Was it called float? Yes, it's called float. So what do we call this? MMM. I think we can actually even group things here in the. Let's see. Category. Yeah, maybe I'm mistaken. Maybe we can't actually group things in here. Never mind, let's just put it in. So, let's call this drive gauge, normal, range, max, RPM, something like that, right? It's a float. The default is probably going to be like, I don't know, 5,000. Yeah, this name is probably way too long to actually be shown there. Drive game. Let's call it normal range. Normal range max RPM. And the description is actually not shown anywhere yet. I just put it in there because I thought it would be good to have. And then this is like normal range max RPM. Like so, and then just have the red range. Sound kind of silly, the normal range and red range, but oh well. Something like that. We need to reload the UI definitions, and then we need to reload this thing, and now we should have these things here. And they can probably be kept at there. Yeah, so here we have it. Now it's actually in the role. That's not good. Did I put it in the role? I did. Yeah, that's not what I wanted. Let's undo everything here, like so, and then put it in here instead. Yeah, here we go. Okay. Yeah, let's keep them at 5,000 and 7,000 for now. That's fine, and that's probably fine for all of these things. So now if we go and have a look at the blueprint file. Oh, that's a UI def. That's not interesting, but vehicle blueprint. It has put in these things for us here in JSON. And I had some other changes here as well. Game unit stuff. But yeah, now they all have their default values. That's good. Okay. And so we can put that in here as well. I always forget that it's not actually at the bottom of the file, like I expect. And what was the actual? It was normal range max RPM and red range max RPM. Like so, and then we can just quite simply put them here as well. We don't need to do anything with that. Yeah, in this case this seems a little pointless, but in many cases what you actually get out of the props is a little annoying to use. For example, just the case that you have to like this props thing is what is actually allocated on the heap, so that you can, it's allocated in the heap using this allocator that you pass in. But the data is actually available then on this value. So you would have to sort of copy this value out of it. And at that point you might as well just tidy it up a little bit. Okay. Cool. Well, now we could perhaps already set the name in the HUD. If we'd like to have something there visible. So let's try something here. We have some message params allocated for us, like so. Can I add strings here? I can add strings here, and they probably have some max length. Well, we could perhaps just send all the information about the HUD when we assign a new avatar, just as parameters of the message, even just the raw string. Yeah, like I said, sooner or later that name is probably going to be some localized ID after all. Let's keep it as it is for now. And now we can then use the init vehicle HUD thing here. So let's send that, and then when we lose the client local avatar, we probably want to send that other one, which is probably called dinit vehicle HUD. Right. I think so. Send message params init avatar roll screen. Yeah, there's a separate message for that, which is fine. There's quite a lot of stuff here that actually goes into initting that screen. What do we add? Yeah, we add like the integers, because that's those are like enums. Yeah. Oh, that's fine. Scope all of this. I actually moved away from this way of naming things. I know it is the official Zig way, I just don't quite agree with it. Snake casing or whatever it's called. Okay, so we can do self context, send message with params means okay messages, and init vehicle HUD, and then message params there as well. And here we will want to send, we want to add a string, bpp display name, and it's probably actually the slice that it wants. Comment that out for now. So that's that. And I think that might be the only thing that we actually want to pass to this guy. Every vehicle which has an avatar tracking component will want to have this. I do wonder if every vehicle will also want to show the gauge, the driving gauge. Maybe it will. So in that case, maybe we'll want to add these, add like the floats here as well. VPP, normal range max RPM, and VPP red range max RPM. Then we get like the whole package in one message. Maybe that's better. Yeah, because every vehicle can most likely be driven anyway. Let's do it like that. And then here in Lost, we do the same. Don't actually even probably need to send any parameters. We can just send message with params. No, especially explicitly no params. So means game messages, game message, dinit, vehicle HUD. Like so. See if that builds. Oh. Right. What do we set that to? I don't know. Actually, that's probably not very good. Let's make it something. It doesn't matter. They're going to come from the JSON data, so it's fine. They can be 0 there. Like so. And in fact, we can just init them here, and we don't need to have those lines there. Yeah, sometimes I prefer to just init everything in one place, and that would be then this init function here. Because now we have some things that are initialized here, and then some other things that are initialized here. It's not always super nice, but yeah, sort of like a personal taste thing. All right. Yes. So now we can then listen to this guy. And that guy sits in the same category as this init avatar role screen. So if we go into the in-game UI view model, on message received, it would go probably here. So game messages, game message, init, vehicle HUD as int. Like so. And then the same thing for the dinit. Like this. And let's get those things out of the messages. So display name is parameters get string normal range max RPM. And yeah, these messages really aren't type safe, as you can imagine. It's a pretty nice message passing system, but it's not nice in that sense. So now we should probably add some parameters to these things. Vehicle info. This is the easier one. I think we already have. Yeah, we already have a vehicle name here. And this is, of course, this is not a struct. We're just writing things directly into the module here. These are essentially global data. I used to be really allergic to global data previously, but like in this case, it kind of just makes sense that they are, because there really is just one. So why make it into a struct when you don't have to do that? And yes, we have a show function taking the name, which I bet we have somewhere here. We have it there. So yeah, let's take that away. Probably want to take that away too in just a bit. But that would be vehicle display name. And yeah, and here we want to we need to capture the error specifically and just show like a fatal error with name there, because this thing doesn't take actually return any errors. And it doesn't return any errors because it's registered with a message node. Message nodes need to essentially take like a pointer to this thing if it wants to run it whenever something some message is received, which means that it can't be a deferred error message handling thing. It can't be like this, because this makes this function essentially like generic. So in this case, I'll just catch it like this and just show a fatal error if we can't show that thing for some reason. And yay, now we have scout vehicle. If we switch, now we have truck number 2. And if we go very close to this, yeah, the distances aren't really adjusted yet. We need to go like super close to this, if I remember correctly. Might actually be that we can't. Yeah, we can't even can't even switch to that with this vehicle. Yeah, I need a whole different sort of system for calculating these distances. But this vehicle, you can just go very close. You can see here that the highlighting debug draw sphere does appear. You can switch to that. Now it says mother there on the right or the left again. I don't know left from right today, apparently. Nice. Nice. Let's get a little bit of coffee. Now if we clear this thing, was it game state maybe? Yeah, game state clear avatar. This is a way to clear the avatar and just set it to nothing, like so. Now we should have gotten rid of this, but of course we didn't yet. So let's fix that as well. So that would be probably just vehicle info hide. And also drive gauge hide, if we happen to have that, and probably like avatar role selection screen hide. Or is it clear? Is clear the thing that we call? No, clearly not. All right, we probably we had that hooked up to some property. Yeah, I need to look into that, but it should also be hidden if it is showing. So now if we have this vehicle, everything is good. Now if I clear the avatar, still actually doesn't get cleared. D-init vehicle hard. Oh, that's why I had it inside an if I should not have. CZ enabled means cruise control enabled. So that's why it didn't fire. And now we actually don't have it. All right. Now we do. Okay. Now if we clear this, it goes away. Right, so the order of these are now somehow a little messed up, right? Let's see. So we init the vehicle HUD, yeah. And we init it again, okay. And now we deinitialize it. Yeah, we probably need to go into the C++ code to see why it's actually. So set the active avatar. This is essentially where we are. And it basically realized that oh, I am not the thing anymore. Yeah, so the order is sort of not guaranteed here. We can't really know if that is actually going to be the case. Okay. So we probably need to like ref count this somehow. We can most likely just do that, at least for now. Let's try that and see how well that works. So var, that would be like avatar. What do we call this? Avatar ref count, probably. It can be like an unsigned integer. We initialize it to false. Whenever a avatar is set, this is incremented. Whenever an avatar is cleared, this is decremented. Maybe that's actually not completely true. Let's call this something like avatar HUD ref count. So whenever an avatar HUD is initialized, that would be deinitialized. Yeah, because it's a different thing setting an avatar from actually initializing a vehicle HUD. Just that they quite often happen to coincide. Yeah. Okay, so here we quite simply want to, let's read the parameters first, just like we normally do. Here we quite simply want to increment that. And here we quite simply want to decrement it. And if this is 0, then we clear the thing. Oh, I missed a V there. Yeah, I don't think this was a thing in Zig. Or is it? Is that a thing? Negation of type. Yeah, yeah, that's like a double negation, so that's not a thing. It's not a thing, basically. Like so. Yeah, I think this should be better. This should work. All right, so now we have the thing there, and now if we clear the avatar, it goes away. Good. And now if we set the avatar, it comes back. We actually only get the scout vehicle because we don't show this other thing there. So we'll want to fix that. Where was it actually? It's in init HUD view. Yeah, this one. This one can just go away. like so. Like so, like so, like so. Okay, so now then, now we'll want to set these things here. We want to give these as parameters as well. So let's call this like normal range, max RPM, F32, red range, max RPM, F32 as well. And we'll want them here as data. Like so. Something like that. Possible underflow, yeah. Yeah, if you mean the this guy, then sure. Yeah, I bet there is a possibility of that. We could probably just like assert that this is larger than 0 here. Yeah, and now it wants these things, obviously. Yeah. Yeah, I actually I was sort of thinking I should probably assert that these are the sorts of things that you think don't happen and then they do happen after all, because you have some weird case where you're actually not initializing, you're like deinitializing 2 vehicles or something, and then it gets negative. That should never happen though. We should make sure that it actually calls them properly. So I like to assert here rather than try to clamp or something like that. I want a clear error if that happens. Right, drive gauge.zig. Right, this guy now should get some sort of update method, and of course we do have one already. We don't really need this probably for anything. Gauge amount runs from 0 to 1. Let's see, where is it? Yeah, 0 is empty, 1 is full. And we want to remap the RPM value into a range that is specified by these guys here. And then finally remap that into like a range that goes from 0 to 1. Something like that. Delta time, I don't know. Maybe we want to animate something. And because of that, we'll want to have the delta time. I think I'll keep the delta time there for now. I can't even count how many times I've thought this will never happen, then end up debugging for a while before realizing, oh, it happened. Yes. Sounds very familiar. Sounds very familiar indeed. Okay. So that goes away. Keep the delta time there for now. So what do we have? We have like it's this guy here. So we have the RPM. We have the speed in kilometers per hour. And we have the gear, the current gear. Maybe we don't want to actually have the speed in kilometers per hour, but instead we want to have it in its raw form, which is meters per second. And then we will essentially remap it there, because if at some point, if I want to have the option of representing speed by like miles per hour or something like that, that should probably be done there in the HUD as well. What do we have here? We have a vehicle controller, vehicle description, means vehicle component. This guy probably knows something about the speed. Does it not? Vehicle state info. It knows the current gear. It knows the current speed forward. Excellent. In meters per second. Yeah. Yeah, these are the two. These are the two ones that we want to have. And engine rotation speed in radians per second. Yeah. Yeah, the rotation speed, like RPM, is pretty universal though. So maybe I'll convert it here and pass it as RPM or something. I think I probably already do that somewhere, right? Huh, maybe not. Maybe not actually. But I bet I do that somewhere. Let's search for RPM. Here we go. Convert from radians to second per radians per second to RPM. So that's the RPM thingy. And yeah, I have some filtering here for the speed. Yeah, probably not going to do that right now. I'm not going to do any smoothing of the RPM changes either. I can do that at a later point if I want to. This is the thing that controls the audio, right? Yeah, this is a timbre event instance. Yeah, so it makes sense to do it here. Might make sense to do it for the HUD as well, at which point we probably want to have like filter it somewhere once and then feed it to everything that wants a filtered value. But let's not concern ourselves with that right now. I'm going to copy those lines and we'll find a suitable place here. Tick movement input is probably not the correct one. I bet it is probably in update. Is client local avatar. This looks like a good place. We have these things there, and then I can take this guy and put it in there at the end. So we'll need a new message for this actually. Let's do where should we put it? Let's put it up here because this is sort of related to the core vehicle HUD, if you will. So probably like update drive gauge. Update drive gauge. And then we need to register the message. Where was that done? I don't remember. It's done in... Oh, it's done here, right beneath the thing. How convenient. Update drive gauge, and the category is game message category.hud. Like so. This avatar component should already be set up to send messages, and of course this is where we sent the message just some time ago, or here rather. And just copy that thing. And we'll just do update drive gauge. So let's see if we can actually read it like this. We have a vehicle controller here. That's fine. It is sort of the client-side predicted vehicle controller, but that should be fine. RPM, yeah, that's a variable because we're actually modifying it here. But we probably don't need that. So let's pass it the RPM. Let's pass it just we can do it like this. We can call it speed and then state info dot. What happened to my LSP? Was my LSP unhappy with me? It's called current speed forward. Right. So this is in meters per second. I think we'll want to do probably like a stud math. Oh, stud math clamp. Any type lower and upper. And actually, I'll just. Yeah, what is the upper? Upper's something really large. Let's give it a large number here. I basically just want to make sure it doesn't go negative. That should just be 0 then. And then we have the gear. And we can do state info. Why does this not want to work? That's weird. That is really weird. Can I build this now? Let's see. I can't build it. That's probably these BPPs here making it confused, right? Yes. Clearly, because now we got an auto fix as well. No, it's still confused though. Oh man. Oh man. Let's try to build this now then. We have some other problems here. Get rid of that as well. And get rid of everything. To please the LSP. There we go. Okay. Yeah, sometimes it just like it gets mad about something and then you're like, oh, I don't know what's happening. Okay, so this is an, we want to probably pass it as an int. And what is this? This is most likely a float. RPM. And speed, and that would be an int 32, so add int gear. And then we uncomment this guy. And that's how we get it into kilometers per hour. That's good to know. Let's try to build this. Yeah, that builds. Let's take this with us. Move over to the drive gauge. I'm going to just copy it in there for the time being. Okay, so delta time. Then we have the speed. That would be speed F32. Actually, RPM was. Let's keep them in the same order. It's nicer. And then gear. And gear. And this can probably be. We can convert it back into the into the enum before it reaches this point. So this would be basis.physics.vehicles.vehicle gear, like so. All right. And here we have it at current speed in kilometers per hour. Yeah, and current gear. Okay, so we can just set this to current gear would be just gear. And current speed. And then we just want here I use the abs, which means that we could use the abs actually rather than clamping it to 0. If we're reversing, then we get the speed as well. That might be all right. But for now, let's just convert it like so. I'm just gonna copy this. Copy that comment there to make sure that everyone understands what is going on. And actually, I think I want to write it like that. Right. Let's leave the RPM for now. We can come back to that. We need to remap it into the range that the gauge expects it to be in. Now this thing is going to be unhappy with us, I bet, because this guy. Okay, so let's just remove that from there. That means that the delta time, yeah, this is where we have the delta time. Yeah, again, if we want to animate something, it's pretty good to have the delta time there. We want to have like a pulsing, glowing thing, which is why I want to keep the time around. Let's make this another function. Like so. I had some ideas for some animations. And we're probably not listening to that new thingy that we created, to this new message, right? Yeah, we're sending it, and we are defining and registering it. So that's okay. Update drive gauge is the name. Let's have it here. Right, and RPM parameters get float. Speed is the same. And then here we can do probably, so it's an integer, not an unsigned integer. Yeah, let's do so const gear equals basis physics vehicles equal gear equals enum from int parameters get int, like so. And then we can do the drive gauge update gauge RPM, speed, and gear. What is that? An int? Current speed is an integer. That's yeah. I was probably actually thinking that I would have that in. It's just a rounded value. Now that I consider it, so let's do const speed kmh, and how do we round things? That's not something you do very often. Is it round? It might be round. and it probably wants, yeah, it returns returns the same sort of thing. Yeah, okay. Yeah. So if we give it this, it will come out as a float, as a rounded float, and then from this we can probably do int from pointer. Oh, is it? Int cast is probably not the right one either, right? Or is it? It might be. No. Yeah, how do I make an int from a float now? Int from bool, int from enum, int from float. No, there was an int from float. I don't know how I missed that. Yes, thank you, Axel. I'm just, apparently I can't read simple lists today. Okay, and look at that. We have a working speed gauge and gear display. Pretty cool. How fast can I go? It's like the immediate question I get now that I can see my speed. I know the mother vehicle is improperly tuned, and it quite simply goes way too fast. It needs to be limited, and I bet this thing is also probably way too fast for its own good. But yeah. Attraction point not have humanoid avatars. Probably not people running around. I've sort of considered taking the same route as the sort of like mud runner, snow runner, those kinds of games where essentially like the characters are vehicles. There will be humanoid characters in the game in one form or another, but not necessarily running around like the game world. But that remains to be seen. I think you will be able to like communicate with your I almost said teammates, but like your colleagues in the story of the game, but they will most likely be represented by like UI elements, things like that. But we'll see. Not sure. Okay, so this works fine. Let's do the RPM next. And that's perhaps slightly trickier. We might have to tune those upper limits. But yeah, I might get way too excited with humanoid avatars at some point. Or like humanoid characters overall. Like the avatar is not really a problem. I already have like character controllers and things working here, which you can see if you look at the Hyper video series I made. There are essentially just capsule meshes. But yeah, it's a whole thing of like asset creation and animating them and all of that. I'd rather have no characters than have like really bad avatars. Or sorry, have no characters rather than really bad characters. So we'll see. Okay, RPM. How do we do this? So we need the value. We want value in like normalized form, like this. I think currently the red section, red section starts at 0.8. That's just how it's set up. And we have the limits. So basically, this should already be in RPM, right? We did convert it. Yes, we do convert it from radians per second to RPM. So that's cool. Let's see. Yeah, so we basically want to remap from 0 to this normal range end. Right. Yeah, this is not super convenient in the form that I have these things now. But let's do it like this. If RPM is below this normal range RPM, then the current what is it? Is it gauge amount is the value. We can use like a remap float method, for example. We do RPM from 0, old min, old max, so that would be G normal range, and this would be then to 0.8. And if we are above that, then we basically map from normal to red, and this would be 0.8 to 1. Yeah, is that the easiest way to do this? Might be. Yeah, let me know if I'm missing something completely obvious. All right. We have the thing. It's looking all right, but like clearly we can't reach the red section now, which is, I mean, not necessarily a problem. What if we get some airtime? Do we reach the red section? We don't really do it. Yeah, it's capped for this particular vehicle at some value that it just won't go over. And that's okay. That's okay. What about if we take one of these? Not that, but that. Yeah, the RPM might be just completely. It's super low, actually. It's kind of weird. It doesn't really move anywhere. But yeah, I don't think this vehicle should go like 100 kilometers per hour, considering how ridiculously large it is. That's not good. Let's add an output here to help us. Call this just RPM, and then probably something like that. RPM. Help us tune this a little bit for these vehicles. Expected 1 arguments font 2. Again, print F is what I want. Right, so RPM is 0, and this reaches something like 3,800 or whatever it was, and then it just won't go over that. But that's fine. It's okay. I'm gonna tune these probably off video a little bit, and this this just goes up to 477 and then doesn't do anything. That's kind of surprising, actually. I wasn't aware that's apparently the maximum rotation of the engine or something like that. So yeah, that needs to be tuned. But that explains why the gauge doesn't go below that or above that. Let's take one of these guys. Yeah, we still have the same, clearly have the same maximum rotation for the engine. So this is not tuned at all either. It's just that you don't really notice these things unless you, like now I let go of the gas, and it sort of lives and changes how you expect it to. But if I just keep the accelerator pressed, it just goes up to that level and then just stays there. So yeah, I was thinking, can I do this with just one remap? So basically, my question is this: with the way we have it set up with the two limits, it's not necessarily a linear mapping, right? Like you can have normal range max be like, 5,000, and you can have the red range max be 5,010 or something, right? It's not necessarily a linear mapping. In the gauge, it is a linear mapping. Like we go from 0 to 1. This is 0. This is 1. This is 0.8. It's a linear mapping. But the RPM scale is not necessarily linear. So that's why I don't think we can do it with one. But I might be mistaken. Might be thinking about this wrong. I mean, it was a somewhat contrived example, I know. It would not be 5,010 if the normal range max is 5,000, but the way we have it set up with these two max thresholds, that is like a possibility. But yeah, I need to like tweak this whole engine response thing a little bit. It's not really my forte, so I'm gonna have to probably dig into that off screen a little bit and make sure that it feels and sounds and looks nice with all of this. But that's pretty cool. That's not for today. Today was just hooking up the UI, and that seems to work quite nicely. So I mentioned the cruise control. We can set the cruise control here. You can see here in the lower right corner. You see it twice every time because it's once on the server and once on the client. But we have the target speed set to 30, and I'm not pressing the gas now. I'm just controlling the vehicle. We can see how well it actually keeps that. So if we set it to 50, for example, then see the response there on the left. Works quite well. See if you drive it up hills and things like that, it stays quite close to the desired speed as well, which is kind of nice. Put it up to 70 and see how that works. Works much better than in my actual real life car, that's for sure. And this is also how AIs drive around the thing, by the way. That's why I have I'm not sure that the cruise control will be actually a thing that the player will get to use, but for the AI, it's pretty handy to just give them a path and tell them, hey, drive 40 kilometers per hour, and then the cruise control tries to match that speed. So that's pretty cool. Okay. Pretty nice, pretty nice. So, next thing for me would probably be to either, do exactly this thing. Hook this thing into the new UI system. Or, alternatively, do, what was it? Yeah, this menu, this role menu here. Actually throw away this thing that we had. Or we can reuse it, but we just need to hook it into the new layout. And then hide that driving gauge when we show it. And that should be nice. And then we have those interaction areas and vehicle switching things. And I've been thinking about how to actually calculate the distance from one vehicle to another, like reliably. Currently, it's just using the transform to transform distance, but that obviously doesn't work. Like if I want to switch to this vehicle, now I'm kind of far from the vehicle center. So that doesn't work. If I do this, now I can suddenly change to it. And I have some ideas, but that needs to be tested as well. Play around with the crane a little bit. Crane is always fun to play around with. Yeah, I think something like 50 kilometers per hour is perhaps like a suitable maximum speed for this kind of vehicle. Considering how big it is. I put a scale mannequin, that's a person right there. If it goes any faster than 50, it's going to be basically like, or it should be basically like a nuclear bomb when you actually drive into something. if you have it driving like 150 kilometers per hour. But yeah, I didn't tweak this vehicle at all, or not enough. I basically just added enough engine power to make it drivable, and then moved on to other things. I really like the Big Bertha vehicle. Yes, I like it as well. I should really put some time into building more gameplay around it. I spent quite a lot of time in the beginning of the project, in the beginning of the transmission video series, working on this vehicle, and then I got a little burnt by that, or like I wanted to do something else, and then I took a break from it. But yeah, I need to get back to doing more things with this, because it is quite cool. Reminds me of my childhood, lying on the floor playing with my Lego Technic auto cranes. Yes, that is sort of the motivation behind these things. Lifting things, but also sort of an immersive sim gameplay idea where you can sort of solve problems in more ways than one, and just letting people mess around with these things and go like, no, I can just go over the obstacle because I parked this thing there, and then I lift like another vehicle over the obstacle and then use that to continue, that sort of thing. I think there should be quite a lot of fun gameplay to be had with all of that. Okay. Yeah, I'm gonna take a slight break. I might continue this stream for a bit more, especially if you guys are still interested in hanging around. I might go make myself a cup of coffee, and then maybe we can continue a little bit. And if you need to run, then no worries. The VOD will be up and all of that. But let's. Where's my cursor? There's my cursor. Let's see. Do I have my my text here still? I don't actually. Or do I? Yes, I do. Hey. We will resume. Let's do that. I'll be right back. Getting myself a cup of coffee. Cool. I'll be back in about 10 minutes or so. All right. Coffee acquired. So now we have some energy again. Let's get rid of that. If you release the game, this state as in some alpha demo of sorts, I'll just drive around in that thing the whole time. Yeah, there is a demo coming. I'd like to have it in a slightly more interesting state though, but sure, yes, there's a demo coming, hopefully somewhat soon. And this is essentially the the demo level, this thing here. There's a little bit of an intro, which takes place in this other level that you might have seen. Basically this thing here. There's this intro which sets up the thing a little bit, and I have some particle tests here currently. Yeah. I don't remember the state of these things, but yes, yeah, that smoke is supposed to be in the level that we just were in. So yes, there's some work still to be done here, but there is a demo coming, hopefully relatively soon. Right, let me adjust my microphone a little bit. Like so. So maybe we'll try to get started on this avatar selection screen here. Where are my... There we go. My layers. Right, so currently the way this works is that if you have a vehicle that you can have multiple roles, and you keep a button pressed and you get this role selection screen, and then you can switch the roles here. So this thing is supposed to replace the drive gauge in that case. Oh, I should take that away probably. We can take that away as well. Build that. But instead of the really ugly placeholder menu we have, the drive gauge should go away. Instead we get this kind of screen. And I wonder if we have everything set up to actually implement this. So all of these elements here are vector based. So here we have these things, and we can just drag them out. The idea being that pixelized UI looks bad, so I use almost exclusively vector graphics. The text actually do get rasterized to a sort of, I mean, everything gets rasterized obviously, but the text gets rasterized to like an atlas, and but the rest of this is essentially like SVG graphics. So if we look here in the UI folder, we have, for example, the HUD. We have the driving gauge base. Edge is fine. Which looks like this. And this is the actual sort of asset that we feed then to the game. Well, it runs through a converter, but that's basically it. We also have the marks. They're sort of rendered because you want this actual like arc to be rendered in between them, so that's why they're in a separate file. Then we have the vehicle info, which has this beautiful car that I drew here, and this is also text vector graphics. And yeah, not everything in this program works correctly in my implementation. I don't support the full SVG, obviously, because that's really quite large and complex, but many things. So here we have the vehicle control menu. Let's see what we have. We actually have just three main shapes here, or two sort of, if we take away the texts, because they're going to come in dynamically after all. And then we have this triangle and this curve. These are sort of like related because they're like a highlight of the selected item. We essentially have only two shapes, these guys. Actually, I brought some things over into another file so that I can work on them sort of in a slightly more game-oriented manner. So maybe we'll bring this over as well, like so. And the idea was that it would fit, these things would sort of run opposite each other. Now I think I've actually resized something here a little bit, or have I? Let's see. Let's take the driving gauge stuff away. That actually does look quite similar. Yeah. Yeah, maybe that is actually all right. Why's my text not rendering though? You can see the outlines there, but they don't actually render. That's weird. Let's undo this for now. Go back here and re-enable those texts. Yeah, that looks like a bug in Affinity Designer actually. Strange. Anyway, let's align this how we want it. Why can't we actually align it properly now? Yeah, I'm not much of a designer actually. This sort of thing doesn't come naturally to me. I just try to flail around in a design program and see what comes of it. Well, that looks roughly all right. So the idea is that it sort of aligns with this side here. The driving gauge actually goes a little over that currently, but I may have changed that in the UI as well. So what we'll want to actually export now then is disable all of these things. Except that we don't. They don't get disabled now. Should I restart this program? This seems really buggy. Yeah, I think I should probably restart this program. Let's see what happens. No. It's always nice when you're working with something that you're not super confident in, and then you have the sneaking suspicion that the program is just bugging out. It's always fun, hard work. So, vehicle control menu is the thing that I'm looking at. Yeah, these things really don't. They just don't go away. How weird. Never actually seen this happen in this program. Everything else seems to work perfectly fine. But these texts, for some reason, they just don't. They don't work correctly. What I would like to do here is export this thing. And typically you do this with something called a slice. This is like basically a portion of the document that you want to export. Let's see, we can probably put this slice on top of this other slice, like so. Maybe we'll make it a little larger in this direction. Something like that. Then we'll call this vehicle control base, probably. Yeah, I'm calling it driving gauge base. And here we should at least be able to like disable these texts. Yeah, they don't get disabled though. This is super strange. I've never seen anything like this previously. Let's see what we actually get if we export this now as an SVG file. So vehicle control base. I think we want it in here. Yeah, we got the text and everything. And that's not great. That is not great. Yeah. Okay. We're gonna have to do it another way then. Let's take the vehicle control menu and just copy over only these things that we actually are interested in. Those probably. Yeah, now we have them. We don't have the texts at all here. That may not be such a big deal. Yeah, that's super strange. I mean, I'm probably doing something wrong, but it does look like a bug. Okay, let's get rid of those and then move these guys into here. That's another vehicle control menu. Oh, is that that is probably the reason. Yeah. Okay, I think I know what happened. Delete that. And go to work, HUD work. Let's just revert this. Revert. Yes. Let's see. Yeah, I think we've had actually several of these things. Yeah, okay. Yeah, so it wasn't bugged at all. It was me being bad. But that is completely to be expected. So that's fine. Right, this is not exactly aligned how I wanted it to be. We will be able to align it in the game. Do sort of the final alignment in the game, so it's not that big of a deal, but let's do it here anyway. And now we can hide these texts like so. That's good. And we can create this slice. This one, leave a little bit of margin. Oh, and I'll want probably actually those things out as well. And this will now be the vehicle control base. We'll want this as an SVG, and we'll put it there. Right, file failed to convert. Let's see what happened. Ah, yes. Yes, this is me being too excited about drawing things in a vector drawing program and then not implementing everything. So basically I read the SVG data, which if you don't know looks like this. And here we have a gradient with 3 stops. One there, one there, and then one there. Yeah, 0, 0.9 and 1. And I don't actually support that. I only support 2 stop gradients. But that's not a problem, because if I remember correctly, this gradient is kind of stupidly set up. So yeah, those colors are exactly the same. We can just remove one of these guys like that and it will look exactly the same with only 2 stops. What about this guy? Yeah, this one also has a 3-stop gradient. Opacity 22, opacity 22. Alright, it's just they're all the same, so it's essentially just a single color. How silly. Yeah, it's just black with opacity 22. So let's make it that instead. Much better. And with that we should be able to export this. So save and export the same slice again. Yes. It should look the same. Still have something. Right. Okay, we still have something with the 3-stop gradient here. Maybe I just need to, actually delete one of those things. What are we actually controlling here now? I'm confused. Yeah, that has just a 2-stop gradient. Okay, cool. And this guy has a 3-stop gradient. We should be able to get rid of that. And that. And now perhaps. Yeah, okay. So now we can see we got a vehicle control base bin SVG, which is like my own format of an SVG image. It's sort of like bytecode, because SVG is almost like, I don't know if it's Turing complete or not, but it's almost like a programming language. Like you give commands to something that renders your image, and then you carry out those commands in a specific order according to some specific rules, and that is essentially what I do when I render the UI as well. So just a bunch of opcodes with some data attached. Okay, cool. So let's see if we can get this thing on the screen. And then add those texts back in. So we already had, in a previous video, created this thing called an avatar role selection screen, which uses a canvas. And a canvas is essentially, in the UI system, which is called Goofy, by the way, and that's why you see it like Goofy all over the place. A canvas is like a widget that just lets you render things from code. So you get essentially a render function. And this is how we render the old widget. If we start the game and turn on this view, enable widget bounds debug draw. You see these boxes here. And yeah, this box is the roll screen. Then you have some other. This is like I don't even remember what that is. I think this is like subtitles. Oh yeah, this is probably like the mission thingy. Can we start? Do we have a mission here? Gate open main, gate close. Gate mission. Oh. Yeah, I haven't run that in a while. Alright. Can't find some global variable. Well. Yeah. That's neither here nor there. But we should be able to use the same canvas to render these new things. And these are also canvases, by the way. Both the gauge and this other thing. So basically what we want to do is just load that image that we just exported and render that as like a background image for the canvas that we want to use. So avatar role selection screen. And let's keep almost everything we have here except the rendering, because this already handles all the roles and everything for us, so that's nice. Let's not break that. Right. Let's do var g canvas. Because I think we might need, to set that up. Yeah, here we're setting, like for the drive gauge, we're setting it, the visibility ourselves. For this avatar role selection, if we can find it here somewhere in the script. Where is it? What was it called? It was avatar role selection screen. Oh, there we go. Yeah, we're binding the visibility to a property. So Goofy supports these sorts of like properties. They can be Boolean values, or they can be vectors or floats or ints, or some maybe color was also supported. And the idea here is that you can bind certain things to a property. So if we're searching for this string, I bet we find it in one of these constants. UI property HUD avatar role selection screen visible. And yeah. And here we're just setting that property, and the widget reacts to it. So it's sort of like a data binding system, almost like inspired by things like MVVM and that sort of thing. So we don't actually need to set the visibility explicitly like this. Do we need the canvas for anything else? Yeah, not really, because we can get the canvas from there. So maybe we don't. Maybe we can use this here instead. Yeah, so now in this gauge module, we're only using the canvas here really to set the visibility. So we probably actually don't need to keep that as a global variable either. What we do need though is something to hold our image. So let's do background and svg image pointer initializes to null. And And here we can do, or actually we can just probably assign it directly to that. So we can do g background equals means UI utils, right? For some reason the LSP got mad at me again. I updated Zig and LSP this morning to get rid of the problems we had in previous streams. Now it occasionally gets mad at me. UI utils should be a thing, but it's not. Why is it not? Why is that not a thing? Let's just copy this straight over from the Gauge one. You can even just use the same string for now. Does this build? It does build, yeah. So yeah, it just doesn't want to list it here. And that's weird. That's really weird. I don't know what's going on. But maybe we don't need to actually spend that much time on that. Let's call that init, because now we're going to need to de-init. We need to release that image at least. So de-init, like so. Yeah, I don't know if we actually need an allocator here, or if we can just... How did we actually render these things? So we have something called avatar role display name, yeah, which takes in a role type. So driver, cargo crane, or attacker crane, and they just return a string. This is not perhaps the nicest way to do this, and you can obviously you can have Zig just convert this into a string for you, but these need to be localized, so that's why I have like a specific function for them here. But okay, so these are the strings that we currently will want to show there, which means that we don't really need to have an allocator. We're just going to work with string literals for now. So yeah, I do pass an allocator to the Gorge though, and then I don't use it actually. Which can be considered a little silly as well. Let's remove that as well there. We don't need it. I do kind of like to keep track of whether or not these modules are initialized though, so that I don't accidentally do like a double de-init or something. So let's just do that. And oh, if we're not initialized, yeah. And then like so. And then we don't want to use that, we want to use the one that we just exported. We can ask the resource path to that from resource manager. Oh, that's not hard view, it is control base, it's that one. That's fine, but that's not gonna compile now because we changed the name. It was called init canvas. Now it's called init instead. And then in here we need to de-init the avatar role selection screen. Oh, and of course we took away the allocators. We shouldn't pass it there to the Gosh. Yes, you can convert an enum to a string indeed you can do that. But of course, I need to actually localize those strings. Like a lot of the stuff actually already works and is localized. Like here, post for example, I have some some languages here. I don't speak French or Italian or German or Spanish, but I do speak Swedish. So the game is actually quite nicely localized into Swedish already. But yes, I know you can convert the enums into strings. That is actually really handy. I do it in several places. Right. Where was I? Yeah, now we want to actually figure out the size of this widget and probably position it as well. Let's comment out this previous rendering code that we had. Oh, look at this. There's an error in zig format. Expected statement found end of file. It's probably because I took out the last. Yes, now it works better. So to render that SVG one, you quite simply need to call render on it, but you need to give it some bounds, and we can probably use the same sort of logic that we do for the gauge base. So this is essentially like the pivot is like left down for this. I think I used left up for this thing here to be able to match them to this position as easily as possible. And the widgets, they do support pivots in Goofy. But when you're rendering with Canvas, you obviously need to take that into account, so it's not as automated as it otherwise would be. And I had some comments here for myself, like if we do something like this, and copy this over. Yeah, the position is probably just the canvas-based position, yeah. Width and height. Yeah, we can just take those over as well. Canvas we do need, indeed. We can call this like base image bounds, probably. Right, so we have position X, then position Y minus height, so we're essentially like left down pivoted. Right? And then we quite simply render the thing. So add a line there to separate our init code from our actual rendering code a little bit. Like so. Base image bounds. So now it will render that thing within the bounds of the widget, but the widget is not correctly sized yet. Right, you can see the bounds of it are here, and we actually render it over here. So with canvases, we don't actually clip the rendering to the widget bounds. That's sort of deliberate, so that you don't have to necessarily move the whole widget around if you just want to move something on the screen. You're encouraged to render within the bounds of the widget, but you're not required to do that. But yeah, it looks like it's probably like center pivoted here. Let's look at the script. What do we have? Yeah, we have UI pivot center. I think we're gonna move this guy down. I'm gonna calculate its size similarly to how I've done with these other ones. So yeah, down left is the thing that we have here, with position 0.2, 0.8. Right, so now it's quite nicely sitting within its own bounds. And this is a little bit of a I wouldn't call it a hack, but it's a way to calculate the size that I'm not like super excited about perhaps yet, but maybe it'll be fine. So we need to determine the aspect ratio of the image, which we can see here. And now, of course, I have two of them on top of each other, so that's not good. I'm just going to write those up or down. 286, 168. Yeah, so that gives us the aspect ratio of the base image that we have. Let's call this like screen aspect ratio. That's confusing, but selection screen aspect ratio is 286 divided by 168. And this is a little annoying that you have to sort of have to keep these things here to actually, if you change that, then you need to remember to get this here. But of course, this thing doesn't know what image we're looking at. So yeah, I'm not super excited about this. But the idea here is that you can give the width of the widget that you want here in normalized coordinates, so like a third of the screen, for example, and then it calculates the height for the widget, taking into account both the aspect ratio of the image as well as the aspect ratio of the UI, because currently we have this UI in a mode where it doesn't actually stretch it. As you can see, it's sort of, if I pause this, you can see it better. It just keeps it there in the middle. I should probably add some black borders or something around the thing, but it doesn't actually stretch the thing currently. Let's see, window dot set size 1080, and we can get back to true 1080. Yeah, so this thing sizes the widget so that it doesn't sort of stretch the SVG image that we've used. So let's see, selection screen aspect ratio. What does that actually look like? That looks all right. Yeah, it's kind of wide actually, so that looks like it's calculating it correctly in that sense. It's not correctly positioned, and it's probably not the correct size though. It's just the correct aspect ratio. But let's see. I think the size or the position is supposed to be this, right? The same as the gauge, and then the size is supposed to be significantly smaller. Start with 0.2 and see how that looks. So that's all right. Yeah, that looks all right. I think we do want to remove any small hacks that we've had though. Right, and now we need these two bounds to get aligned. Yeah, and you can see that they are actually aligned as long as we have the screen the right size. So now that they're not aligned, that means that this is slightly too large, because you can see there's like a wider gap here than we have here. So let's make it slightly smaller. Annoyingly, that whole menu goes away when we reload this thing, because we're not like resending the avatar messages But of course that's like a development thing, so it's not the worst thing in the world. All right, we're getting closer. Not quite there yet. Maybe 14. Let's try with 14. Still not quite. We can see that it's supposed to be as high as the gauge actually, and it looks like it's actually a little lower. Yeah, there's no method to this madness. It's just trying things, basically. I think that's probably close enough, isn't it? Then we'll move it a little off to the side. Yeah. Yeah, that looks actually almost completely correct. Now, of course, we're rendering two of these elements at the same time, so that's a little annoying. And the interesting thing here is that we're binding this visibility for this thing to this property, and this gauge thing should have essentially like the opposite binding. When the avatar selection is visible, the gauge should be invisible, and vice versa. I wonder if we have an easy way to achieve that. I don't know. But let's figure something out. How do we listen to properties? There's my Goofy here, and Goofy has something called a Goofy Manager. And this handles properties. Yeah, we have actions, and we have action callbacks, register property, get property type, set property value, and then get property value. Yeah. Yeah, this is a little hairy because this needs to interoperate with C++, so it's not as nice as it perhaps could be. But it's all right. It's all right. Can we get a callback when a property changes? I don't think we can. We can get a callback when an action fires. Yeah, that we can do. So Goofy actions. There's some main menu actions, there's some pause menu actions, and some game over menu actions. The game over menu is actually not used in means currently. And then we have some properties, campaign active, interaction prompt visible. Yeah, and then the role selection screen, visibility, and the index is also actually handled via a property, which is kind of nice. I sort of like the idea that this thing, just reads an index like this, the get property value, and then that is the thing that actually renders the correct highlighted item there. So that's nice. But now we will need to actually get the property for the gauge. I mean, we can do that in the update method of the gauge module. It's a little annoying that we have to do that, but maybe that is just what we have to do currently until I come up with something better. Let's add a variable here called temporarily hidden, which is set to false initially. And I like to actually specify the type of these things, especially when they are global data. So temporarily hidden is false by default, and if we are temporarily hidden, then we don't actually hide this widget. Instead, if we are temporarily hidden, we just return. We early out here in the render method. Yeah, this is a little nasty to do it like this, but let's do it like this for now. I think this will actually be a pretty easy way to get this working immediately. And then read property. Get property value is the thing I want, and the type of the property is a boolean, and the name of it is means.ui constants. Something with avatar, right? Or was it role selection screen visible? And that's got a bit long, so let's break it onto several lines. Yeah, that should be it. That's everything we need to do. And of course, if we are not visible, then we don't really need to update this at all. So if gcanvas base is visible, like this, and then we don't need to do this check. I mean, it's not a super expensive check, but yeah, I don't know. Like now we're doing 2 checks that actually go into C++. It was actually easier to just do this, not really care. We have only 1 check. It's probably better if we consider that from like a performance perspective. All right, so now if we hide this, then the gauge goes away, which is nice because it's sort of like immediate mode in the sense like we still update it and everything. It's sort of stateless. It's temporarily hidden, so it just doesn't render itself. Yeah, that's nice. Okay, so now then, what was the text that I was planning to render here? See if we can find it. Let's hide the gauge base. So vehicle control is what I've called it. We'll see if that is what we will actually call it in the end. But for now, let's call it that. Here we have some commented out text that I can remove. And there's some commented out stuff here. And that's fine. Avatar role selection screen. Should we rename this to vehicle control screen or something? I think we probably should, so we don't use. Yeah. Oh. I'm just gonna keep it for now. We have the properties named after this as well, so maybe it's actually better. Okay. So the first thing that we'll want to render then is the title text. Right. And we can take something like, actually the vehicle info text rendering is probably closer to what we want here. All right, what am I doing? There's something to figure out here. Yeah, that looks fine, and that's like a blur shadow if you want a blur shadow. Now, did I have some kind of? I do actually have a blur shadow here. We can do a few different sorts of shadows with Goofy. You can blur the text, which can let you do both sort of blur shadows like this, but it can also like make the thing look like it's sort of lit if you draw it in like a bright color and then draw it on top of the text instead of below. And those things actually work in the game as well. But then we can do another kind of shadow, which is of course like rendering the text underneath the actual one with a little bit of an offset. So if we make this larger, we can see that we're rendering these with like blur effects to make them seem like they're like lit a little bit. But then we have this vehicle info thingy. If I make it larger, you can perhaps see that we're actually rendering this text sort of twice, once with a little bit of an offset and like another color. I think that we might actually want to use this offset shadow instead of like a blur shadow for these texts. I think that probably will look better, even though I have them with like a blur shadow here in this outline or this mock-up. So let's try with that. I'm going to copy all of this into here, and this would just be title text. Right. NVG, yeah, okay. I bet I have to just shorten to NVG, Goofy, NVG. So if you don't know what NVG is, that stands for Nano VG, and it's this wonderful vector drawing library that I'm using to do most of these things. Nano VG. It looks like this. And it's a very small library, and it contains a very simple C API to just draw things. And it handles things like anti-aliasing and Bezier curves and things like that, which helps you immensely when you're trying to render like an SVG image. Or any kind of vector image, really. And so NVG is the way that we actually render well, almost anything in the UI system in Goofy. So what is bounce here? Let's see. I copied it from vehicle info. Let's see, what is bounce? Oh, bounce is just the bounce of the whole widget. That's good. We can call this just bounce because it's the bounce of the whole thing. That's cool. Bounce center Y. Yeah, I bet that's just, yeah, it's literally just the bounce center in the vertical direction. We don't need that. I'm just going to want to render this text here, which says vehicle control. Let's add something like title text center Y. And we're going to have to actually find that place. That would be minimum Y plus, and then some value. Then some value times the height of the thing. So we can go with like 0.1 times height. And that would be the title text. We can take that away. That's some hack from the other thing. Pixel size X. Yeah, I don't know. What was the idea there? Pixel size X. Right, so pixel size is just, it just comes from there. When we call it something different here, that's why pixel pos like that. Okay. The string that we'll want to actually render here, the text, if you will, is vehicle control. Did I have it with a, no, it's with a small c. So that's fine, we can put it there, and then if we render the shadow, again, we can have it there as well. Something like that. And then the X, pixel name pos X. So we have like bounce min X. Yeah, that could be all right. Let's see what happens if we try that. I have a trick up my sleeve to actually. Oh, it's running actually. I have a trick up my sleeve to actually make tweaking these things easier and faster. What was the error that we got? Invalid bytes. That's fine. Okay. Right. So we can see that it's not actually all that far from being good. The size is too small. Needs to be pushed a little downwards and a little to the left. So how do we now tweak this without having to recompile all the time? Well, use something called the canvas user data. The canvas user data is just a vector 4. And we can see here that we've actually used it with both the info canvas and the drive gauge. So just put it in here as well. And now we can use this for anything you want. So X, if we start with that, there was like an X offset of 0.14. That was that. We had a Y offset as well, 0.1. And then for the C, we can, for example, use the font size, so 0.04. And we can just immediately make that larger, so 0.08, for example. And now, because this script auto updates, we can just do ud.z, ud.y, and oh no, that was ud.x, and where was the here ud.y. Yeah, maybe we don't need actually to have another member for that. This is nicer, ud.y. Like so. If we build this, we should be able to tweak that much easier. Just, you know, waiting for proper DLL reloading to be available. Alright, we can see that the font size is perhaps quite good already. Let's see if we can tweak it a little more. Yeah, this of course now sort of goes away when I let go of the button, so we're gonna have to just try this. Hit the button some more. Let's move it a little to the right. And let's move it a little downwards. Something like that. Yeah, it's almost good. Maybe 15 and 0.8. Went a little too low, I think. 14. That's pretty good. It's interesting. It looks a little blurry or weird. Yeah, now it's usually a good idea to make sure that it actually scales properly. So now if we make this like way larger, yeah, it does look like it's supposed to. Sometimes you do something wrong and then it clearly doesn't scale how it's supposed to. Some text just gets like twice as big when it should get something else. But that's okay. It does scale properly. I still think it looks a little blurry when it's that small, but maybe it's a matter of setting the colors correctly or something. And then it's just that it looks blurry against some of the backgrounds, but not others. Yeah. Yeah, I think that's probably all right. Now we can even if we want to, we can hard code those values in, so we don't have to use the user data for those kinds of things. So we have, what do we have? 0.08, 0.08, 0.14, and what was the font size was there, and that was also 0.08. Like so. Now we can see that we're not using the user data anymore because we got this autofix line there. So in that case, it's actually kind of handy to have those autofix lines appear. All right, we don't use any blur shadows. We can take that away. And now then, we want to render the roles, and we want to also render this thing. So I wonder if we should actually, maybe we'll draw the text first, and we'll make it so that the one that is highlighted is sort of lit up like this with like a little bit of a blur, similarly to how we light up the gauge texts. And then I'll put in this thing afterwards. I need to export this as an SVG as well. That shouldn't be a problem, but let's do the text first. So how do we do that? Well, we basically have the thing here, right? Put a line there. That was the old text. Let's see what we have. So we have G roles. This is updated using some kind of mechanism. Add role, append assume capacity. This is probably a bounded array with 16. Yeah, that's bound to be good enough. Oh, and here we have this line, which we can essentially just move up here to the beginning again. Highlighted index, pixel pos, it's supposed to be like that. And we have a bunch of stuff here that we don't really want. Oh, what did I do? I don't know. Right, so the highlighted index, yeah, we're drawing a rectangle with a somewhat dark color behind the one that is currently highlighted. Then we're setting a white color. That's probably not something that we want to do. We want to use, what do we want to use? Yeah, we want to draw the thing with a shadow like this. Should we make a function to do this? Shadow offset in pixels, yeah, and then the string. Yeah, let's make a function to do that. So we have like draw text. And we have like the pixel position. Draw text with shadow or something. So pixel pos, that would be a vector 2, probably a basis math vector 2. We have a pixel shadow offset, which would be a float. And then we have the string. We also have the color. Right, so that's just the turquoise color, and that's the, yeah. Yeah, I don't want it to be turquoise though. I think I want it to be some sort of white. Let's put in a color here. That's fine. Basis color, like so, and then the actual text, which is a const slice of U8, and it's a void function. And we'll take these things. Oh, we need the rendering context, which is of course the way we actually access the whole goofy rendering thing. Right, pixel pos, yes, and then we have the pixel shadow offset, like so, and we have the color, which is right there. No, actually, that's the shadow color. Let's leave the shadow color as a hard-coded thing, at least for now. Yeah, that's better. And then we can take these away, and instead we do raw text with shadow. That's just context. This would be vehicle name pixel pos, which is not correct actually. Let's call that something else, but just for now. Shadow offset pixel. Color would be this UI color HUD turquoise or turquoise, or however you say it. And text is just text, like so. So let's call that title pixel pos instead, like so. That's good. And this would be title pos. Yeah. Oh, that's probably fine. We don't need that. And we can break this onto several lines. That's a bit clearer. We have some old crap there as well. And now then, highlighted. Yeah, let's see. So we wanted the blur to be there. Right. We wanted the blur to be there if we are on the highlighted one. But that of course needs to happen after. Yes. Yes. Maybe we can even add a boolean here called blur. I'm thinking like if we're not blurring, I might have to change this, but let's try with this. If we're not blurring, then we're rendering the shadow like this. If we are blurring, it probably makes sense to not have any shadow at all. And in that case, we need to set up the blur. How did we do that? That was the thing here too. Yeah, font blur 16 looks pretty good, and then we set it back to 0. So yeah, just draw the same thing again. Text Y, yeah, okay. That's something from the old one. Looks like we're actually like unused capture. Okay. Well, autofix it for me then, please. Looks like we're actually, yeah, we're incrementing in like this was poorly done, because here we are incrementing the pixel positions, so that wouldn't scale actually. Oh, right, we need to put in the blur thingy here, so false essentially. Yeah, this would not have scaled properly. This old version. Let's make sure we do that properly now. Right, so that still looks good. And if we scale it up to like 55, it still looks good. Okay. All right. Yeah, because like the UI uses like normalized coordinates. So for example, within this widget here, we have like 0, 0 here in the top left corner and 1, 1 here in the lower right. And then based on some of those coordinates, we can calculate the actual pixel coordinate where we want to draw something. NanoVG works with pixels. And so we want to, when we move from like the first element to the next one, we don't want to increment the pixels actually, because then in this case we would always have moved 30 pixels. But instead we want to increment the normalized coordinates and then calculate the pixel value based on that. So let's do like var text y. And this is now not pixels, but instead normalized. Let's use 0.2, start with that. And how did we do this now? So I think can do var text x. This is not going to change between the elements. We can do something like 0.18 or maybe 0.1 is all right. Like it should be indented a little bit from this vehicle control text. So that's that. Okay. What then? Yeah, we could maybe actually use this as, or have this like as a vector 2. So let's do like a var line position, probably. This is math vector 2 init, and for the x we feed that one, and for the y we just start with something, and then we figure out if that is actually okay or not, like so. And it's unhappy with me because it's never mutated, but I will mutate it in a bit. Actually, I can do that right now. Let's do line pos y plus equals, and I don't know, 0.2 maybe. And now it's not unhappy with me anymore. Right, and then out of that, yeah, shadow offset. These will be the same for all of the text, so we can take them out of that and use the same. Font size probably the same as well, isn't it? Yeah, it looks like it's the same font size, so let's use that, move that out of there as well. And now then, now we draw this, and we have line pos. So line pixel pos. Like so, And the text is this thing that we looked at earlier. Textual representation of the role, which we need to localize at some point. This will probably not look good. And now, of course, now we need a vehicle with actual like roles. Oh, that's not such a thing. Let's delete that and put in this instead. Oh, and you can you can see we clearly did something wrong here. And the wrong thing that we did was, of course, that we need to have bounds.min.y plus, and then that. Why were they rendered on top of each other, though? That's probably because that needs to outlive the for loop. Like so. Now then. Right. Yeah, and I have another bug here. You can see that it actually looks exactly like the x coordinate calculation. I just kind of forgot about that. Always need to scale with the width and the height of the widget. These canvases tend to be somewhat complex to render. There are other widgets like buttons and labels and image boxes and things like that just handle all of this automatically. But all right, so now we have something a little more nice. So we need to start further down, but then I don't think that there needs to be this much space between them, and then they need to be a little to the right as well, so that we have some space there for the little arrow that we will want to put there, like this thing. So the starting position was a little further down. Let's make it 0.3 perhaps, and then let's make that 0.15. I'm not going to use user data now. I think we're pretty close already. And maybe we can even blur the thing already. Like if that is true, right? Then we'll blur it. Can get rid of that completely, and all of that too. Let's see how that turned out. Yep. Well, now you can see that we can actually select these things, and we can already see which one is the active one. They just need to move down a little bit further, and then that's probably it. And then I'm gonna want to have the color be something different. Let's put in UI color HUD white, which we'll just put as white currently, but we might want to change later, so let's have a constant for it here. So white, and let's start them off even further down, 0.4 maybe. Yeah, this is sort of annoying. If I did this a whole lot more, I would put in a script for myself to actually automatically set a mother vehicle as the avatar, so I wouldn't have to do that. Okay, I changed the wrong color. I do think there probably actually needs to be a little more space there. Let's make it like 17. And this is supposed to be turquoise, and this is supposed to be white. Let's move that up ever so slightly. And then again, we need to make sure that this scales properly. All right, this looks better. But yeah, I think the white here is a little too white actually. If you look here, it's not actually white. It's not quite white. It is actually white, but then the opacity is down to about, what is that? 180 perhaps. So we can try with that. Let's try with 180. UI constants. So we do this, and then we do 255, 255, 255, and 180. Yeah, that looks better. Doesn't look that nice when we don't have the highlight there yet, but yeah, this is pretty nice still. Okay, let's try to do the highlight still. Now that we're somewhat on a roll here. So, how would I do that then? I don't exactly know. Maybe I'll just put in another slice here. Slice this guy up. Like so. Can just keep that arrow there as part of it. Does it actually have a shadow? Yeah, it has a shadow. I don't think we don't support shadows on polygons like that. Oh, like a blur shadow, so it needs to be disabled. What about this guy? Does it have any effects? No. Does it have a gradient? It does, but it only has 2 stops, so that should be fine. Yeah. And what about this size now? 256 by 32. That's nice and round. Nice power of 2 values right there. So let's do that, and let's export this, and we'll call it vehicle control highlight probably, and we'll give that as an SVG, and we need to disable a whole bunch of things here. Otherwise we'll get all of, oh, we actually want that one, but we don't want almost anything else. Like so. Can we actually center this better? I'm so fond of my power of 2 values that I don't want to resize this guy, but can I center it a bit better? Not necessarily. That's probably fine. Let's keep it like that. And then we'll see what we get. So that looks good. Sometimes you can see that you actually accidentally brought something else with you into these SVG files. But here we have we have the mission thingy. That's not good. That's completely unnecessary, but it doesn't contain anything. Like the mission is essentially this. That's the mission, the sort of briefing. And actually, we got it as a container here in the SVG file. Our own converter will then get rid of that. So it's not the end of the world, but we can just remove that. What else did we have? Vehicle info as well. Just remove that as well. Vehicle control menu. Right, so that's probably the little triangle, and then this is the the highlight, and that's it. And then it has the one linear gradient, which is this thing here. So now we can export this again, and we should have less data there. Yes, so now got rid of those. That's better. So let's see about that. Let's see about rendering that. I think we should be able to do it quite easily. Actually, let's do highlight, and it's also a goofy SVG image pointer. What was the path? Oh, height light, highlight, like so. Variables must be initialized. Oh right, that's not supposed to be a colon, but with an equal sign. And then we deinitialize it like that. And now then, if we are actually well, there will always be a highlight graphic there. It's just a question of where is it, so to speak. So if we just do like highlight render unstretched, probably context is context. Position can be, we can just put in line pos, I think, right? Does that actually want? Yeah, that doesn't work with pixel things, I think. Let's try with that. And then we'll put in width, and it's going to be a little too wide, but that's probably fine. Probably fine for now. And then we could do goofy UI pivot, and probably like center left, I think. How are we actually aligning our texts? Yeah, we're setting the text align here as left and middle. Yeah, that's like an NVG align thing, and this is a goofy align thing. So there's like left and middle here. It is called center left. They're essentially the same thing. So this should give us something. It's not going to be in the right place. Let's just get an overall feel for what it looks like. Yeah, you can see it there. It's a little difficult to see, but you can just about see it being there. Okay, good. Let's see. How are we actually? Highlight boss. This needs to be further to the left. Let's make that happen. Oh, that's const needs to be const, otherwise it's unhappy with me again. Yeah, the width was actually kind of all right. I think I might actually want to have it a little wider still, because the thing is that that's the width of the whole control base, and that's the width of, yeah, it is actually not as wide as the whole control. Maybe it's actually what we want. Let's see. Yeah, you can see it just very faintly sort of go off to the side here. Yeah, it's a little confusing. Let's scale that up quite a bit. See what we get. Yeah. Now we somehow lost the text. Oh, this doesn't have. Yeah, it's again. There's some bug with this hot updating these things. But yeah, okay. We can just see that it's very much to the right. It should be further to the left. It actually looks to be kind of nicely vertically aligned with this text though. So let's just put that to 0 for now, and if it is indeed what we want, if we don't want to add anything, then we can remove it completely. Yeah, so it is not exactly what we want, but we just want to offset it much less than originally. Yeah, this is a case where I should probably use the user data trick to sort of hack this into place. But I'm not sure if I can be bothered with that. Yeah, that looks good. That looks pretty much correct in my opinion. We can live with that. And I would just need to make it actually move with the selected thing. Like we're not doing that yet. And then we'll be done. Then we will be done. Right, so the highlight, let's put in like a highlight. Oh, actually, maybe we can just use the line height directly. Let's call this line height. We can just increase the line position by that. And then this highlight position needs to be below that, because we will use line height times, and then probably float from int and highlight index. Would that work? Float from int must have a known result type. So probably SF32 or something. And that should be clear enough for it. Oh, yeah, that doesn't look correct. What did we do? So we have bounds min y plus height plus line height times the index. Yeah, so the first one is quite all right, but then it goes way too far actually. Why is that? Oh, it's probably this. Yeah. Yeah. So that is line height, right? It needs to be height times 0.7. Otherwise, we get the whole screens height times 1.7. Yeah. We need to shut this down for it to be able to recompile. Now maybe. Yes. Okay. Finally. And now we should just make sure that this actually scales properly. So let's make it like ridiculously large. Need to flip some avatars here probably. Yep, it looks like it scales properly. And I think 0.15 was what we wanted originally. Yeah, hot reloading the script breaks our avatar selection logic, but that's not really a problem. That's like a development thing. But yeah, hey, that looks better. It's not super readable on against all kinds of backgrounds, this thing now, but of course this level is not fully decorated or really decorated at all currently, so I'm not super worried about that. But it's an observation to make that it's not super readable against the current checkerboard texture and colors necessarily. But yeah, works quite nicely still. Of course, these guys don't have any role except the driver role, so they probably shouldn't even be allowed to go into that menu, but it is there for now. Just can't really do anything with it. Okay. Yeah, I think I'm pretty much done with the work I had sort of set out or put aside for myself for today. So next thing would be these interaction prompts like this, and then just doing this mission thing here. Those are kind of small in comparison. Well, yeah, this works nice. And somehow I feel like it just looks like a game immediately when you have a little bit of UI on the screen. It'd be interesting to see if I can make it look nice so that these UI elements and widgets sort of react to the movement of the camera a little bit, so that it would sort of float around just a little bit. But we'll see if that makes sense to do. It shouldn't be super tricky to calculate the relative movement of the camera and then just have those move in the opposite direction or something, a little bit like that. Okay. So, do we have any people left in the chat? Concurrent viewers 4 at the moment. Do you guys have any questions or comments or wishes or anything? Is there anything in particular you would like me to cover on stream in the future? I've been basically just mostly sort of working on the game in the order that I need for the game to progress, but if you guys have anything that you would in particular like me to cover, then why don't you put Zig in the title of the stream so the bot can promote it? Yeah, I sort of saw that at some point and figured I should perhaps do that. So how does that work? Is it just, do I just need to mention Zig? Or did I need to put in sort of like a lightning bolt emoji or something? What was the idea there? No wishes, first time watching. Well, no problem, and welcome. Hope you got something out of this. It got sort of rambly, but these things kind of tend to do. You need both Zig and the bolt. Okay. Okay, cool. I'll try to remember to do that next time. What is the genre of Traction Point? That's a good question. I guess in one sense it is sort of like a puzzle game. In another sense it's a driving game. It's a physics playground. And it's probably all of these things. But yes, it is a game where you will play through a somewhat linear campaign. We have levels that are reasonably large, but at least the plan is that you progress from like one level to another. Like this is somewhat large, and this has already at this point has some distinct areas. The idea is that you sort of move between these, and there should at least hopefully be more than one way to solve the sort of puzzles and obstacles that you come across. And then you move to the next level where you have sort of the same sort of deal. So a linear but hopefully somewhat wide linear game. In addition to that, it is also a very much like a sandbox game, and I hope to make it somewhat possible to create new content easily, since I own all the tools. I have the option to release all the tools that I want and make it moddable. But that's more sort of like a general wish than an actual promise at this point. Thankfully, it's not another roguelike survival, because we have plenty of these. Yes, we do. Nothing against those per se. I'm not very good at roguelikes. And I tend to get somewhat annoyed at losing my progress, even if it can be really, really fun in the moment. But yes, it is definitely more of a handcrafted experience in that sense. Or that is what I'm hoping. It is of course also possible that I simply cannot produce everything I would like to do, and it ends up being more of a sandbox system, because it's kind of easy to add new things. Like you can even just create new vehicles completely from data already at this point. You don't really need to code anything to add a new vehicle, for example. So it should be it should have the opportunity to be a quite versatile sort of sandbox playground if people like that kind of stuff. How many are working on the project is basically just me. Everyone working full-time on the project. Everyone, i.e. me, am not working full-time on the project, no. No. I have a couple of friends who have helped me out. You may or may not know that this is sort of a reboot of a project that I had previously called Project Slide, which also running on the same engine. We can play a little bit of Project Slide here if I can get it to launch. Let's see. let's see. Oh, we need to convert the assets for slide. Project Slide was sort of an earlier attempt at this. It's not written in Zig. It's running on the same engine, but it's a C++ game. And a lot of the engine work that went into Project Slide now benefits... Oh, damn. Maybe we have a pre-built exe somewhere. Let me see. Oh, this is actually kind of old, isn't it? Yeah, somewhat old. Let's see if it works still. Oh no, not combat demo. No, that's a really old one. No. Don't I have actually some newer build here? Probably don't. Nah, anyway. Yeah, Project Slide is sort of a more, how should I say? It was supposed to be more combat oriented, and also use, shall we say, more high fidelity assets, if you can call them high fidelity. The reboot, which then ended up being called Traction Point, is basically the same project, except it's rewritten in Zig, the actual game, and I've toned down the combat a whole lot. Mainly because just driving combat AI turns out to be really kind of tricky. And then I changed the intended art style to be a bit more low fidelity. Let's see if I can actually take the means data. Take the tools. I just probably haven't updated the tools because I've made some changes to the SVG files recently. And we put these in work folder root tools. Like so, you can see that some of those were actually updated there. And then we'll just do a force reconvert all files. And this will take a while. Wasn't Slice going to capture the flag? No. No, I don't think so. It means some sort of multiplayer capture the flag sort of thing. I might have had some test game mode that was capture the flag at some point, but no, not particularly. Impressive what you have done so far. Well, thank you. Yeah, some of the stuff is actually pretty nice, if I may say so myself. But of course, like it's sort of difficult to judge based on when you sort of sit and look at these things for a long time, you sort of lose the perspective a little bit. What do you work on when you're not working on this? Well, I do work for a games company as a tech programmer, so I do the same thing but elsewhere. Yes. On much larger projects where I have much less say. But yes, that's very nice. Nice to be able to just go meet some people and talk about things. Because it's not super easy to work on something like this for long periods of time, like without external input, as I'm sure you can imagine. But yes, I was actually supposed to tell you about some other people who have helped me in the past. Like, for example, some of the music in Project Slide is made by another guy. And I have another acquaintance, another ex-colleague who has done some narrative stuff. Basically, some writing for Project Slide, and I hope he'll do another pass on Traction Point when I get the narrative side a little further, because he's a much better writer than me. So not completely alone, but mostly a solo developer. Right, so we're rebuilding or reconverting the slide data. Let's see if we actually get this thing running. It's not really related to Traction Point, but it would be interesting to see if we can run Project Slide, because while I've made changes to the engine and the tech, I've tried to keep that project working at all times, because it is the one that still has the more sort of benchmarkable data. It has a fully decorated level, for example. So let's see if we can get that building. $270 assets left to build. Takes quite a long time to convert data for Project Slide. I should probably just optimize my converters a little bit. And yeah, I will probably end the stream in about 10 minutes or so. I've been going for like all of the afternoon almost. But let's see if we can get Slide building still and play a little bit of that. I've been meaning to put out the Slide demo level at some point. It's super raw, and especially the AI is just unbelievably stupid sometimes, which was sort of like the thing that made me realize that I can't build this kind of game by myself. But it's still pretty fun to play. What is there? Okay. So all the files converted successfully. That's nice. All right. So you have perhaps seen this scene and this level from some of my other videos. Just keep this. So I don't know how well this runs on this machine. Hopefully well enough. But yeah, this level is sort of represents the visual target that I was going for at the time, and I think I reached it quite well actually, except for some things that I still don't feel actually look all that nice, like the grass doesn't look all that nice. But yeah, this is basically the same vehicle that we have in Project Traction Point. It's just sort of fully modeled here. It uses the exact same physics data for this kind of thing. You can see here's an untextured well, piece of a spaceship basically. I never got that far, but right. I thought in Slide there was supposed to be two teams fighting fighting with each other. No, it was supposed to be a single player game as well, at least like, sort of mainly. But there is multiplayer support in bases, and I might have shown some of that off. Anyway, here you have like actual like firing combat, that sort of thing. You have this railgun, which is super difficult to actually aim with. But if you can actually figure out how to aim with them, you can see there like this AI guy is shooting me, and now they just drove into the ditch. We can blow them up with this railgun like so. Boom. And here we have another guy that's probably gonna drove into a rock trying to evade me or something. So this is not completely hopeless, but there's a little bit of AI work still left to do here before this is actually sort of fun. And these people are somewhat blind. You can drive actually quite close to them before they actually realize what is what. Oh, and then here's something that I actually never fixed. I changed the level geometry a little bit. You can see that there's actually like scripting here. Like one of the people now tell me that there's like 2 more of these so-called combat badgers that have approached from the other area, and there's like proper mission scripting and everything here. So I'm kind of proud of that. But yes, that was one place where I changed the level geometry, which means that one guy just always got stuck there. And this is actually probably the place that just sort of works the best combat-wise. This area right here. And those AIs are essentially completely unscripted, and so yeah. But now he drove into the rock again. So yeah. Particles deprecated, yeah, sort of. I have a new particle system that I showed off in a recent video. Deprecated, perhaps yes. I mean, you can still use it. Traction Point doesn't really use that system at all. Or maybe it actually does. Maybe I have like one or two particle systems there using this system. You can definitely use it, but I have a, in my opinion, much better, much more flexible system now based on like node graphs. And yeah, I need to do a particle pass on Traction Point and add in all kinds of dust and smoke and everything to that. And now we have this guy here. We're supposed to pick up like a trailer. From this garage. And then we switch vehicles again, and you get to sort of haul out the trailer, which I think is pretty fun actually. So now we can switch to this guy, and we can open up and connect to the trailer. The trailer actually doesn't contain anything currently, but I do have support for tracking like dynamic objects that are sort of contained in something, and that's supposed to be used in Traction Point as well. And now this is kind of cool. Like that other guy now is scripted to follow me around. Occasionally he does things like that. Not showing his best side right now. But basically, now I have no idea what's going on. Basically scripted to follow me around and essentially sort of protect me, in air quotes. So you can just drive around this area. At some point there's going to be another one of the enemies attacking you, and and he will fight that. But this is pretty fun because you can just essentially drive around here and your friend will try to follow you as best he can. Occasionally he does really well. All right, my phone was ringing. Sorry about that. Anyway, let's see if we can find this one enemy here and have our friend destroy them. And of course he's so bad at actually fighting that I had to like temporarily make him invulnerable for the mission to make sense. So when we reach this lowest point, there should be more enemies coming, and our friend here is heroically driving off. Oh, now we're stuck on a rock. And they're just driving into each other, but all right, you lost sound. I guess you lost sound temporarily, yeah, because I had to take a phone call, but I hope it's back now. But yes, so this was sort of the deal, and Traction Point is probably not going to look quite like this. I tried to go for a slightly more low fidelity look. I mean, Basis handles this kind of stuff like evidently, as you can see here, but it takes quite a long time to produce this kind of stuff. So hopefully going with a slightly more cartoonish art style allows me to just create content easier and faster. Right, and now when we get here, we should end the mission. There we go, yay! So that's it, basically. It would still be pretty cool to build this game someday, but yeah, I'm gonna need to have one or two people working on it with me. Maybe I can launch Traction Point, and then this can be done as sort of a community project or something. That would be fun. But yes, I think that pretty much covers it for today. Do you guys have any final questions? Yeah, and we do have actually multiplayer as well. This goes into like a really crude internet. Actually, we don't have any internet servers running, but you can create like LAN games. And some of this might actually even work. But yeah, we'll see if multiplayer is something that will come later. Cozy, yes. Yeah, it looks kind of cozy actually. It was supposed to be a little more dystopian, but it turned out kind of nice looking. I have worked on Slide since 2018, so so close to 6 years now. And traction point, well, not even a year actually, but you can see that from the state of the assets. Like this stuff is basically created. This area here is basically created during maybe like 1 week or something, and then I'm just so many things to work on here. Like we have, as of today, we actually have working HUD elements here, right? Actually, very few working HUD elements in slide. So in certain areas, we're almost like further along on traction point now than we're on slide. Well, I guess I had like 1 or 2 elements there working, and subtitles for the dialogue, things like that. But yeah. Yeah. Keep bike shedding my engines and not focus on anything. Yeah, that sort of happens. I mean, I bet I would have something I could even release today if I just bit the bullet and not switched projects. I would have just kept working on slide and not do the whole zig wrapping thing. But writing zig is actually sort of a nice change to, like, in my other work, I just write C++ all day, and I don't particularly like that. So this is sort of a pretty nice motivator to get to write zig every now and then. Super impressive, all the things you have done so far, all the tooling and demos and whatnot. Yeah, I hope to put out some stuff relatively soon, and I hope to actually be able to put out some of these tools. Maybe not at the same time as the demo, but hopefully like this year. Actually let you people play around with this. Should be quite moddable. So that's something to look forward to, I hope. Anyway, I think I'm gonna end this stream now. This was really pleasant. Thank you to everyone who joined. I know that the timing was sort of abrupt and not. This was hardly like streaming prime time. But I hope you guys got something out of it as well, and I actually did get some proper work done during the stream with the whole UI thing, so that was nice. Anyway, thank you to everyone who joined. Be sure to subscribe if you haven't done that. If you haven't done that yet, and I'll try to be a bit more. I'll try to announce my streams a bit more in advance in the future, if possible. I know I'm still not very good at doing that, and I'll try to figure out the zig and lightning bolt thing as well. Hopefully we can get more people to hang around. Anyway, thank you.